What's the difference in current draw on a Particle Xenon with the radio off and on? A Particle Xenon is the go-to device for monitoring sensor data in low-power applications. Although at the time of this video, Particle hasn't yet released the ability to put the MCU and radio to sleep, we can work strictly with the radio. In this video, we learn about using both the manual system mode and enabling the system thread so we can take control of the mesh radio ourselves. Let's see what kind of current usage we get with the radios on and off. All right, so in this video, we're going to be looking at some of the Xenon power requirements, because basically this device that we're building has to work out on a patio without any power, and so it's going to be battery managed. As of the time that I'm doing this video, unfortunately, Particle has yet given us an ability to put the Xenon to sleep, but I did think it would be interesting to at least do some of these power measurements so that we can see at least what effect the radio has when we're transmitting and not transmitting. And then once we can go to sleep and do a real deep sleep, we'll do some other measurements at that time when that's available. So over here, what I've got is basically the closet display, which is our Argon, which is our border router, communicating with our display. And currently it says it's waiting for temperature data, and the old pops up if it doesn't get an update after so much period of time. So that will change over time. I've got the code down in the links below in the video description. So if you want to try out the code yourself, it's there for you to do. And then what I've got here is our temperature sensor, and I have disabled the power to the MCP 9808 just so that it's not consuming any power or futzing with our numbers at all. And then I've got a couple of power leads that we will power it externally when we do the difference between doing the power via USB or doing it through the 3.3 volt. And as you can see here, I have a USB cable that actually goes back to my computer so that I can reprogram this for the different scenarios. And what we've got here is essentially just all I've done is sort of strip away the insulation to get to the power wire, and that's what we will hook up this meter to, and that's what will give us various data. So we'll clip these up. And that green light says that it basically got through either turning the mesh network on, or it got through setup, and at this point it's in a stable situation where we can then do various measurements. Okay, so what we're going to do first is look at our code that I've sort of set up here, and I've modified our code from the last video just so we can do some of these tests. So one of them is going to something called system thread enabled. So what this is doing is really, because we're running under an RTOS, we can actually get multi-threaded capability, and the device OS actually uses a system thread or a thread of its own if we tell it to be enabled. And what that means is that the call to setup and the call to loop all happens on a separate thread, and therefore those are going to run right away. And I like that because it kind of lets the background thread or the device OS thread do all the things that it needs to do to keep the networks up and running, and the messaging and the mesh network and all of that, while the code here can run completely independently from that to do the things that I want my application to do. The other thing is system mode manual. The point of this is that we're telling essentially that background device OS thread that we're going to tell it when we want the radios on, and when we will ask it for when we're connected, and we'll wait for that to happen. So we'll be synchronizing with that other thread as a part of this process, but the system thread or the device OS thread is not going to go off and do anything on its own. We're going to control that. So essentially coming down here, we have the same pin mode D4, which is set to output. That's our green LED. And then here is where we're going to turn on the mesh network, but we're going to leave it off to start with. And once we power up, we're going to just turn that LED on for 2 seconds, and then we're going to loop with nothing there, and that'll give us essentially this number right here through the USB with mesh off. And then we're going to go ahead and build and flash this onto the board. And then once we do that, what we're watching for is this green light to flash once. Once it has, then what we can do is we can reset the meter. Now I have this set to do milliamps of current, and I have the math set to do an average. So essentially right now, this is just sitting here. You'll notice that it's just breathing white, which says that the network is off, the radios are off. We're not consuming any power from the LED. We're not consuming anything from the SPP 9808. However, we are still going through USB, which means it still has to go through the LDO to convert the 5 volt down to 3.3. And that does use a little bit of current. And so we'll actually be able to test this and see what that current looks like. So for now, that's our first test. It looks like we're at about 8.6 milliamps. So we'll pop that into our spreadsheet here. And now let's go ahead and do another test. So I'm going to set this back, and we're going to come back here, and the only change we're going to make now is just to turn our network on and connect to it. So we'll change that code. We will go ahead and reflash. And now these numbers are sort of invalid because the average is still averaging us going through the DFU mode and so forth. As soon as this builds and runs and we get the green LED, so now if I turn it off and on here, so we start it again. So now we've got the radios on, and it looks like we're averaging about 17 milliamps. So radios are on, but we have no, we're not sending any data. So that's our number for number 2 here is 17. And now let's publish some data. So we'll go back here, and we'll come down to here, and I'm going to continuously publish this data. So we'll save, we'll put it back in DFU mode, and we'll go ahead and build and run. So we get our green LED, and we'll notice we see updates over here immediately because we're just sending a 22, and we'll go ahead and reset the meter so it starts a new average, and it shows that we're averaging about 23.8 milliamps while we're actually sending data. So we'll put in 23.8 there, and that's good. So now what I want to do is rewire this so that we can get the LDO out and just give it direct 3.3 volts. So what we're going to do first is, while I'm here, I'm going to recode it to get it back down to the state where we don't have any radios on. So we're in DFU mode. And we will go ahead and build and download. So at this point, we should get back to our 8 milliamp reading. So we have a green. We do this. Okay, so we're showing we're averaging about it's like about 8.6 milliamps. So now what I'm going to do is rewire this. So what I'm going to do is take this out, and we're going to wire it up with this power supply and the meter in the loop, and we'll start getting some new measurements that way. The other thing to keep in mind is the enable pin here will be set to ground. Okay, so now I've rewired it. I've basically got the power coming out of our power supply going through the meter, coming through to the black, which then comes into our power here, and then our black goes there back to the power supply. And I've already set the power supply to be at 3.3 volts. So let's go ahead and turn this on. Notice the green light comes on right away, and let's go ahead and reset the meter to start doing new averages. And we can see that we have a new current reading that looks to be about 7.47, almost 7.5. So if we put that in here at 7.5, we see that the LDO itself is pulling about 1.1 milliamps. And that would be true for doing this for both the mesh not publishing and the mesh publishing. So there we go. That is our power measurements.